Hello everyone. In this macro video, I will talk about how to plot time response of a given transfer function using MATLAB. For example, I will plot the impulse response of a transfer function given in tutorial 1, question 3. If you look at your tutorial questions, you will see that we have a transfer function h of s equal to 2s plus 1 over s squared plus 2s plus 5. And the question asks about the impulse response of the system and the exact response. The impulse response of the system is given in the solution part of the tutorial. If you look at here, we have the impulse response as yt equal to 2e minus t cosine 2t minus 1 over 2e minus t sine 2t. What I will do in this micro video, I will plot the response of the system subject to this response, and also I will use the MATLAB impulse command in order to plot the response. To use MATLAB, we need to define first transfer function. To define the first transfer function, we need to define numerator and denominator of the transfer function. If you look at the question, the transfer function is 2s plus 1 over s squared plus 2s plus 5, which means that numerator is polynomial order 1 with coefficients 2 and 1. So in MATLAB, I define num, variable num, with coefficient of numerator. Then I define the denominator as, if you look here, we have the second order polynomial s squared plus 2s plus 5 with coefficient 1, 2 and 5. So I define here 1, 2, 5. Then I need to use the MATLAB command tf in order to build up the transfer function. So I define h equal to tf num denom. As you see here, I have the transfer function h equal to 2s plus 1 over s squared plus 2s plus 5. So I want to see what will be the response of this transfer function or this system subject to impulse input. To do this, I need first to define the range of time I would like to have the response. So for example, let's say t is defined from, which t means of time, from 0 with increment 0.01 to, let's say, 10 seconds. So I have build up the time vector. So if I define y as the output of the system equal to impulse h and t. H is the transfer function we define and t is the time domain or time range. If I run this command, as you see, I have a vector of the response in terms of time. In order to see the shape of the response, I use the command plot, t as the x-axis of the plot and y as the vertical axis of the plot. As you see here, this is the response of the system. One useful command in MATLAB is help. If you use the command help for any other commands, for example, let's see impulse, you would get the proper information in order to how to use or run a command. If you follow this instruction, here is a given impulse, is say precisely in detail information how to use impulse function. You can use this command help for any any comments of the MATLAB. But in general, it's better to write your MATLAB commands in M file format. In order to do that, you need to open up a new MATLAB editor. here. So I write down the code here. First, I use the CLC command, clear your MATLAB window, and then I use clear all, clear your MATLAB workspace in order to avoid any misuse of the variables which has been already defined in MATLAB workspace. Then I use the close all, which means all windows or all figures already have been opened will be closed after running this M file or MATLAB editor. So now I define my denominator, which was 2, 1. I use semicolon in order to avoid showing or the result of this command when running this M file. Then denominator equal to 1, 2, 5, semicolon. Then I define the transfer function tf num denom. Then I define my time range or time domain with proper increment, which is 0.01 here till 10. Then I use the MATLAB impulse command ht to build up the time vector, response vector y. Then I use plot t as a x-axis and y as vertical axis of the plot. So before running, I need to save the M file. I will save it in my desktop as example, save, and then I run it. In order to run the MATLAB file, I need to use this green play button, or I can use the shortcut button F5. Both do the same thing. So I run it. I need to change the folder. As you see, here is the plot I have done. So in order so far we have done the plot using impulse command. If I want to check the response of the system based on the formulation we obtained, yt is 2e minus t cosine 2t minus 1 over 2e minus t sine 2t. To plot this one, I have two choices. One choice is to use the for command. For example, for t equal to 0 to 0, 0, 1 to 10, y I, in order to avoid, because I have two y, I will use y, another command, for example, y1 equal to let's see, 2e minus t cosine 2t, 2 multiply to expansion minus t multiply to cosine 2 multiply to t plus minus 1 over 2 e minus t sine 2t. Minus 1 over 2 exponential minus t multiply to sine 2 multiply t. I need to define, before that I need to define variable y. I define I equal to 0. In fact, variable I is a counter for this loop. So before that, make sure that we are using minus 1 over 2 e minus t sine 2t. Yep. So here, then I need to build up my time vector, ti equal to t and end. Then I used plot command again, t comma y 1. If I use plot twice in the same M file, the point is that MATLAB will clear the previous figure and plot the new figure in the same window. To avoid that one, I can use the command hold on in order to have both plots in the same window. So if I, and usually the color of the plot for MATLAB is blue one. If you would like to change the color, you can use here, define, for example, color red in order to have different plots. If I run the MATLAB file, look, this is the first plot. MATLAB is still running the second one. I think MATLAB, no. Let me see what's happened to this plot. Okay, let's run it again. I think something was wrong. Let me save first. First save, then run. Okay, the first plot. Oh, I made a mistake, sorry. Here is command T. I use the capital T for the plot, so I run it again. Yes, I have two plots. So if you look at here, if you look at MATLAB MATLAB figure browser, plot browser, I have two plots, but they have been overlapped because they are exactly the same. The blue plot is from MATLAB impulse command, and the red plot is from the solution, analytical solution of the transfer function subject to impulse function. So hopefully that helps. We can also use another way to solve this, to find the exact solution. Instead of using the for loop, I can use y1 or define y1 as the multiplication of this vector t. Because I have defined variable t already as a vector, if I use dot star here, dot star and dot star, I can use variable t as a vector and run it again. If you look, I made a mistake. I need to remove I here. I need to remove I, yeah, and then run it. First save and then run the code. think it's error somewhere. Oh, sorry, I need to define variable t again because I don't have any more t here, t, so I need to run it. Yes, so this is the solution of this problem. So as I said, you have two ways to run the YT using the analytical solution. Either use the for loop in order to count t at each time, or use the vector t as defined before in order to find the response. Okay, hopefully this micro video help you to learn how to use MATLAB commands in order to plot time response of a given transfer function or a linear system. Have a good day. Bye.